Introduction. Steel arcs of freedom. World War II, raging across the vast expanses of Europe and Asia, was taking on increasingly ominous dimensions. Yet one of the most insidious and deadly theaters of this global conflict was not the trench-scarred front lines, but the vast, treacherous Atlantic Ocean. It was here, in the cold and turbulent waters, that the Battle of the Atlantic unfolded. A campaign so vital that its outcome threatened to determine the fate not only of Britain, but of the entire Allied cause. The early 1940s were a time of desperation and mounting dread. The British Isles, the last bastion of resistance against Nazi Germany in Europe, depended entirely on a constant flow of supplies from across the ocean. Food, fuel, weapons, raw materials for industry, all of it had to be delivered by convoys across the Atlantic. Yet every day, tens and sometimes hundreds of thousands of tons of vital cargo sank to the ocean floor, entombed in the steel hulls of torpedoed ships. German U-boats, like packs of predators, hunted down defenseless merchant vessels, turning them into flaming pyres and mass graves. Allied shipping tonnage was vanishing before their eyes, and the shipyards couldn't build replacements fast enough. We are losing this war before our very eyes, in the cold waters of the Atlantic. We need ships, more ships, and we need them yesterday. These words, written in the memoirs of a British admiral, vividly capture the atmosphere of that time. This was more than just a military crisis. It was an existential threat. Without supplies, Britain faced starvation and economic collapse, and its fall would have spelled the end of any hope for a second front and the defeat of Nazism. The situation had become so dire that U.S. President Franklin D. Roosevelt, fully aware of the scale of the catastrophe, made a truly unprecedented decision. He declared that shipbuilding was a higher priority than the production of tanks. At first glance, this may have seemed paradoxical. How could cargo ships take precedence over the armored vehicles needed on the battlefield? But Roosevelt understood a simple, brutal truth of war. Without supplies, without the ability to transport soldiers, equipment, and resources across the ocean, there could be no front lines. Without these steel arcs of freedom, all efforts to produce weapons and train armies would be in vain. Britain, and with it the free world, was suffocating. What was needed was a visionary, someone capable of overturning traditional approaches to shipbuilding, someone who could deliver thousands of new ships to the Allies in record time. And such a man was found, though he was far removed from the traditional world of naval engineering. Part 1. The man who couldn't build ships. Paradoxically, salvation for the Allies did not come from traditional shipbuilding circles, but from a man who, before the war, had no connection whatsoever to ocean-going vessels. That man was Henry Kaiser, a remarkable American industrialist and engineer whose name was firmly associated with large-scale projects, but certainly not with shipbuilding. Kaiser's biography was the story of a successful land-based engineer. Before the outbreak of World War II, his company, Kaiser and Associates, had not built a single ocean-going ship. His specialty lay in truly massive infrastructure projects that stunned the imagination with their scale and complexity. It was his name behind the construction of engineering marvels like the Hoover Dam, a symbol of American ingenuity and power. He also oversaw the building of the San Francisco-Oakland Bay Bridge, an exceptionally complex structure linking both sides of the bay. These projects required more than just technical knowledge. They demanded phenomenal organizational skills, the ability to coordinate vast resources, thousands of workers, and intricate logistical networks. Kaiser did not bring with him deep expertise in naval architecture, seaworthiness, or traditional construction techniques. What he brought to shipbuilding at that critical moment was something far more valuable: a culture of gigantism, precision planning, and an unprecedented ability to manage massive workforces and material flows. His thinking was that of an industrial innovator, one accustomed to standardization and mass production. He didn't think in terms of individual ships, each a unique masterpiece, but in terms of standard designs and assembly lines. To him, a ship was nothing more than a complex product, one that could be broken down into components, standardized, manufactured in parallel, and then assembled with maximum speed and efficiency. An anecdote from that era perfectly illustrates this mindset. It was said that when Kaiser first looked at a set of ship blueprints, he asked a question that shocked seasoned shipbuilders. Why can't we build them like cars on an assembly line? The veteran yard workers, used to shipbuilding cycles that span months or even years, simply chuckled. They couldn't imagine that this outsider's land-based perspective, free from the dogmas and traditions of their trade, would become the key to a revolution that would change the course of the war. Kaiser was no shipbuilder, but he was a genius of organization. And at that critical juncture in history, that was exactly what was needed most. Part 2: Liberty, the birth of an ugly genius. To truly grasp the genius of Henry Kaiser's organizational approach, one must look at the very object of his production, the Liberty ships. These vessels became the workhorses of the Atlantic, a symbol of resilience and mass production. Yet, for all their historical importance, the Liberty ships were, at their core, quite modest, and by the standards of their time, even outdated. The original design that became the foundation of the Liberty ships was British, developed well before the outbreak of the war, and even then it was considered obsolete. It was a simple, no-frills cargo vessel powered by a triple expansion steam engine, a technology dating back to the late 19th century. The Americans modified the design, introducing changes to simplify production and improve survivability, but the core concept remained: a cheap, highly standardized ship that could be built in vast numbers, quickly and efficiently. The Liberty ships' greatest strengths lay precisely in their simplicity. They were dependable, capable of carrying substantial amounts of cargo, and, most importantly, they could be produced with astonishing speed and economy. In wartime, when every minute and every ton of steel counted, these qualities outweighed any flaws. Mass production became their most powerful weapon. But the Liberty ships were far from perfect, and their shortcomings were well known to the sailors who manned them. They were slow, their top speed rarely exceeded 11 knots, making them easy targets for submarines. Their construction, based on aging blueprints, also drew criticism. Among the sailors, there were jokes about their rattling hulls and sluggish pace. With typical dark humor, crews reinterpreted the ship's classification code, EC2, emergency cargo, Type 2, as emergency construction. There were even unsettling rumors circulating about the welds, a revolutionary new technique in shipbuilding, potentially splitting open during storms, further tarnishing the ship's reputation and adding to the anxiety of those who sailed aboard them. Yet, despite all the complaints and criticism, Liberty ships were absolutely essential. Their unofficial nickname, Old Indispensable, perfectly captured the mixed feelings they inspired, a grudging acknowledgement of both their structural shortcomings and their irreplaceable role in the war effort. These ugly geniuses were not elegant liners or sleek destroyers. They were industrial soldiers, clumsy but loyal, performing their critical mission without glamour. And it was precisely this basic, uncomplicated design that allowed Henry Kaiser to unleash his revolutionary production methods, turning shipyards into true assembly lines. Kaiser was no shipbuilder, but he was a genius of organization. And at that critical juncture in history, that was exactly what was needed most. Part 3: For brilliant decisions that changed everything. It was in the context of building the simple yet critically important Liberty ships that Henry Kaiser was able to apply his revolutionary methods, approaches that would forever transform shipbuilding and influence global industry at large. His genius did not lie in inventing new technologies, but in the unprecedented reorganization of existing processes. He introduced 4 key innovations that, when combined, led to a phenomenal acceleration in production. Welding instead of riveting. Perhaps the most radical technical change was the replacement of traditional riveting with welding. Historically, ships were assembled using rivets, hundreds of thousands of them, to join sheets of metal together. This method was labor-intensive, slow, and required highly skilled workers. Kaiser, however, bet on welding. The switch to welding brought a host of crucial advantages. Speed. Welding was significantly faster than riveting. A single welder could do the work that previously required an entire team of riveters. Weight savings. Welded seams were lighter than riveted joints, allowing for a slight increase in cargo capacity. Unskilled labor. Training a person to weld was much quicker and simpler than training a riveter, who had to perform more complex and precise tasks with multiple specialized tools. This opened the door to mass recruitment of new workers. Of course, the shift to welding wasn't without risk. In the early days of its widespread use in shipbuilding, there were concerns about welds becoming brittle in cold temperatures, potentially causing cracks or even catastrophic failure in the harsh conditions of the Atlantic. But the speed and cost efficiency of welding far outweighed these fears in wartime, and the technology was constantly being improved. Modular construction. This innovation was a direct result of Kaiser's builder-engineer mindset, not that of a traditional shipwright. Instead of building a ship step by step, from keel to superstructure, Kaiser introduced the principle of modular assembly. Each Liberty ship was divided into approximately 250 individual sections, large, standardized blocks. These modules could be built in parallel at different factories, even those located far from the shipyard, or in different workshops within the same facility. Once ready, the sections were delivered to the slipway, where massive cranes positioned them like pieces of a giant puzzle. This drastically reduced the time a ship spent on the slipway and allowed for optimal use of production resources. Assembly line production. Kaiser brought automotive assembly line principles into the shipyard. A ship didn't sit idle in one spot throughout the entire construction process. Instead, it moved down the line from one workstation to the next. At each stage, new modules and components were added. As the ship progressed, it gradually took shape, gaining hull sections, superstructures, and equipment, transforming from a collection of parts into a fully operational vessel. This allowed for a tightly regimented and optimized workflow, eliminating delays and bottlenecks typical of traditional shipbuilding. A workforce revolution. To execute such a vast and fast-paced program, an enormous labor force was needed. Kaiser actively recruited from demographics traditionally excluded from shipbuilding. His shipyards were filled with women, who would become icons of wartime labor as Rosie the Riveter. Men with no prior experience in ship construction were also brought in. The key lay in rapid training. Rather than creating universal shipbuilders, workers were trained to perform one or two specialized, well-defined tasks. A woman could become an excellent welder or crane operator without needing to understand the full complexity of naval architecture. This focus on specialization and task simplification made it possible to build a huge, effective workforce in a remarkably short time, one capable of sustaining unprecedented production speeds. Together, these four innovations created a powerful synergy that transformed Kaiser's shipyards into industrial powerhouses, capable of producing ships at a pace no one had thought possible before the war. This wasn't just engineering. It was a revolution in production itself. Part 4. A record that shook the world. 4 days, 15 hours, and 30 minutes. November 1942. The war had reached its climax, and the need for ships was more urgent than ever. It was at this moment, in Henry Kaiser's shipyard in Richmond, California, that an event unfolded which stunned the world and became undeniable proof of the brilliance behind his approach. The goal wasn't merely to build a ship quickly. It was to set a record, one that would send a message to the world, both enemies and allies alike, about the unprecedented power of American industry. Imagine the scene: a deep California night at the Richmond shipyard, a vast, glowing anthill of activity, where thousands of people and machines worked in unison, pulsing with relentless energy. Day and night shifts rotated without pause, keeping the line moving nonstop. Dozens of welding torches erupted like mechanical dragons, sending showers of sparks across the dark as workers in protective masks labored shoulder to shoulder. The air was thick with the sharp ozone scent of arc welding and the pungent heat of raw steel. The pounding of hammers, the screech of cranes, the hiss of gas torches, and the roar of diesel trucks all blended into a deafening symphony of industrial warfare. Everyone present, from engineers to line workers, from men to women, knew they were part of something far greater than the construction of a single ship. They were making history, not in military headquarters or on the battlefield, but here, among slipways and steel, transforming raw metal into steel arcs of freedom. At the heart of this monumental effort stood the hull of a ship soon to bear the name SS Robert E. Peary, honoring the famed American polar explorer. On paper, it was just another Liberty ship, identical to thousands of others. But its destiny was to be extraordinary. At 12:01 a.m. on November 8, 1942, the keel was laid. From that moment forward, workers driven by a shared sense of purpose moved with astonishing speed and precision. Prefabricated modules were brought to the slipway, cranes positioned them with clockwork accuracy, and welders fused massive sections together in a continuous flow. With each passing hour, the ship took more and more shape. Tension mounted as everyone realized they were racing toward a record. It had been officially announced that the entire process, from keel laying to launch, would take less than a week. But as the hours ticked by and work moved even faster than planned, it became clear something historic was happening. Legend has it that the record was achieved thanks to a wager between shifts, a spirit of competition that spurred the crews to surpass themselves. More likely, it was a brilliantly orchestrated propaganda event. Both the U.S. government and Kaiser himself understood the psychological power such a feat would have. It would boost Allied morale and strike fear into enemy hearts, showcasing the sheer industrial might of the United States. And so, on November 12, 1942, just 4 days, 15 hours, and 30 minutes after the keel was laid, the SS Robert E. Peary was launched. The result was nothing short of shocking. Before Kaiser, building a single ship could take months, an average of 230 days. Now, it could be done in a matter of days. But this was more than a number. It was a thunderous challenge to the enemy, a demonstration that American industry was not only resilient but capable of outproducing its foes at a breathtaking pace. We weren't just building ships, we were rolling them off the line like cars. Every new ship was a nail in the coffin of Nazism, recalled one of Kaiser's shipyard workers, capturing the sense of triumph that filled the air. The Robert E. Peary record became a powerful symbol of how civilian genius and cutting-edge production methods could shift the very tide of global conflict. Part 5. The Legacy of the Old Indispensables, Results and Reflections. The Liberty shipbuilding program, led by Henry Kaiser, became one of the most significant industrial achievements of World War II and had a profound impact on its outcome. What began as a desperate effort to save Britain from a naval blockade turned into a triumphant demonstration of industrial organization and engineering vision. The results speak for themselves. A total of 2,710 Liberty ships were built. This was an unprecedented number of vessels produced in such a short time under wartime conditions. These steel arcs of freedom, though often dismissed by sailors as ugly and unreliable, became the vital arteries through which Allied supply flowed. They carried approximately 70% of all cargo shipped under the Lend-Lease program. Without these ships, the transatlantic delivery of food, ammunition, machinery, fuel, and raw materials on such a scale would have been impossible, leading inevitably to frontline collapse and potentially catastrophic consequences for the Allied cause. Every Liberty ship that reached its destination was a small victory that brought the world closer to the final triumph. Interestingly, despite rumors of brittle welds and their nickname Old Unreliable, many Liberty ships proved surprisingly durable. Around 200 of them remained in commercial service until the 1970s, proving their reliability and economic value in peacetime as well. This durability is a testament to the quality of materials and workmanship involved, despite the aging design and rapid production process. Problems were promptly addressed and improvements implemented on the fly. Today, 2 Liberty ships survive as floating museums, serving as living monuments to that extraordinary era. The SS Jeremiah O'Brien in San Francisco and the SS John W. Brown in Baltimore. These vessels offer visitors a rare, tangible connection to the past and an opportunity to witness firsthand the ships that helped win the war. The story of the Liberty ships is not merely one of shipbuilding. It is a powerful example of how organizational brilliance can triumph over traditional technology, and how the mindset of a builder-engineer can outpace that of a conventional shipwright. Henry Kaiser didn't invent new engines or hulls. He took an existing, simple, and outdated design, but reimagined the process by which it was built. He proved that the solution to even the most complex, large-scale problems doesn't always lie in revolutionary technology, but often in revolutionary thinking about process. Kaiser's methods demonstrated how astonishing results could be achieved through modular construction, assembly line production, welding, and a bold new approach to workforce training and deployment. His shipyards became laboratories for innovative management techniques and mass production methods that would later find applications far beyond shipbuilding. The Liberty ships became a symbol of American industrial might and adaptability in the face of overwhelming challenges. They proved that even in a time of total war, civilian ingenuity could be a decisive force in achieving victory.